All right, this is 7.3, video 3, rational equations. A rational equation is where you have usually two or more rational terms. Like so, and you need to figure out what are the x values that satisfy this equation. So rational equations can generate extraneous solutions or loci variant answers sometimes. So I'm going to show you an example of that, which is similar to question 10 in the workbook. So if I have 6 over x plus 1 equals negative 3 over x squared minus 1, the first thing I want to do is get the rational pieces together on one side of the equation. So I'll just subtract and I get 6 over x plus 1 plus 3 over x squared minus 1 equals 0. The next thing I want to do is get all of my rational terms over the same denominator. And so the way I do that is by multiplying by cross multiplying. Sorry. So 3 over x squared plus 1, I multiply by x plus 1 over x plus 1. And 6 over x plus 1, I can multiply by x squared minus 1 over x squared minus 1. And when I do that, I have introduced a Loci variant, i.e. extraneous solution, possibly because now I'm multiplying by a version of 1, x plus 1 over x plus 1, but that wouldn't work if x were equal to negative 1. So I may end up with solutions that don't satisfy my original equation. But I will continue forward with the process, just remembering that I need to check at the end and prune any Loci variant solutions. So here I have 6 times x squared minus 1 plus 3 times x plus 1. And since these denominators are now the same, I can combine them and put them all over the same denominator. And now I can say, well, if I'm dealing with that, now I can just multiply both sides by the denominator, and then it will cancel, and 0 times anything is 0 as long as that thing is a number. And again, that's where we run into the possible problems. But now I have 6 times x squared minus 1 plus 3 times x plus 1 equals 0. And I've gone from a rational equation to a quadratic equation. If I multiply it out, I get 6x squared minus 6 plus 3x plus 3 equals 0. And combining terms, I get 6x squared plus 3x minus 3 equals 0. And using the quadratic formula, there are two possible solutions to this quadratic equation. One is x equals negative 1, and one equals x equals a half. But I know I may have some Loci variant solutions, and so I need to check both of them. So I check in my most original equation, 6 over negative 1 plus 1 equals minus 3 over negative 1 squared minus 1. But that's 6 over 0 equals 3 over 0. That's not true because you can't divide by 0. So x equals minus 1 was a Loci variant solution. Is it possible that x equal to half is a Loci variant solution? It's possible. It's unlikely because we probably wouldn't give you questions where neither of the possible solutions work, but you still want to check. 6 over 1/2 plus 1. Does that equal minus 3 over 1/2 squared minus 1? 6 over 1 plus half plus 1 is 6 times 2/3, which is 4. Minus 3 over 1/2 squared minus 1 is minus 3 over 1/4 minus 1, which is minus 3 over 3/4, which is also, or negative 3/4, which is also 4, and so that works. So we have a solution to our rational equation. Let's see. I will do one more. This one's going to look pretty nasty. X plus 1 over x plus 6 plus 1 over x equals 2x plus 1 over x plus 6. So the thing you keep in mind when you're doing rational equations is you end up with a whole bunch of x's that you have to work with, and that can be pretty exhausting. So step 1 is to get all your rational pieces over on one side equal to 0. So x plus 1 over x plus 6 plus 1 over x minus 2x plus 1 over x plus 6 equals 0. Step 2 is to get them all over the same denominator. So I have an x plus 6 and then x. So I multiply my first term by x over x. I multiply my second term by x plus 1, or sorry, x plus 6 over x plus 6. And I'll multiply my last term by x over x. And technically I'm multiplying the right side. Oh no, not yet, not doing that yet. That all equals 0. So now they all have the same denominator, so I can combine the three fractions. X plus 6 times 1 is still just x plus 6 minus 2x squared. Or sorry, I'll leave it unfactored first. X times x plus 1 plus x plus 6 minus x times 2x plus 1 all over x times x plus 6 equals 0. And again, this operation here could have potentially introduced a Loki variant solution, so I'm going to have to check and prune any later. But for now, I'll keep working forward. I can get rid of the fraction by multiplying both sides by that denominator, because anything times 0 is 0 as long as that thing is actually a number, which it may not be. But for now, I'm not going to worry too much about it. Those cancel. And now when I write the next line, I'm also going to multiply this all out. So I have x squared plus x plus 6 minus 2x squared minus x, because that negative goes through to the plus 1 equals 0. And I can actually do some canceling. I have an x squared here and a minus 2x squared, so that gives me just a minus x squared. I have an x plus an x minus an x, so that gives me a plus an x. And I have a plus 6 equals 0. And now you can use a quadratic formula, or you can factor. But if you factor, you have to be really careful. You have this minus out here. So you can't just look at two numbers that add to be 1 and numbers that add to mean that multiply to be positive 6, because you have a minus. So first you'd have to factor that minus out. That becomes an x squared minus an x minus a 6. So if you're going to factor, you have to start by factoring out the minus. And now you can look at this term, two numbers that add to negative 1 and multiply it to negative 2 are x minus 3 and x plus 2. Is that right? I believe so. Yeah. All right, and when you do that, you're seeing that x could equal 3 or x could equal negative 2. But we might have Loki variant solutions, so let's check them both. And you do that by putting your answers into the very original equation, which is x plus 1 over x plus 6 So let's write them down with the threes. 3 plus 1 over 3 plus 6 plus 1 over 3 equals 2 times 3 plus 1 over 3 plus 6. That's 4. That's 9. 1/3 is the same as 3/9. That's 6 plus 1. That's 7. 4/9 plus 3/9 equals 7/9. So we're okay. So this works. There was no dividing by 0. That's an actual solution, not a Loki variant. Now let's check this one. Don't stop and just assume because one worked and the other didn't. It's possible that they'll both work. -2 plus 1 over -2 plus 6 plus 1 over -2. I really should put a question mark there. Does that equal 2 times -2 plus 1 over -2 plus 6? So that's a -1, that's a +4, 1/4. -1/2 is the same as -2/4. And over here I have, that's a -2 plus 1 is a -3 over 4. -1/4 minus 2/4 equals 3/4. So actually in this rational equation, we had no Loki variant solutions. Both of the answers we got worked in our original equation. So those are both correct answers. So a rational equation doesn't have to give you extraneous solutions or Loki variant solutions, but it can, and that's why you always need to check. I believe that is all the types of questions. So now let's just summarize. Solving rational equations. Step 1, you don't have to do it in this, have to do step 1 first, but let's stay consistent. Get all terms on one side so that it equals 0. 2, cross multiply to get a common denominator. 3, combine the rational terms into one fraction that equals 0. 4, multiply both sides by the denominator. This is where you can get Loki variant solutions, i.e. extraneous solutions. Earlier I said it was here, that's not quite right, but either way you can get them in the process of solving a rational equation. 5, now you don't have, let's see, now it is just a polynomial. At least the ones we will give you will be just polynomials. Probably they will actually be quadratic. So solve the quadratic equation. Check your solutions for Loki variants, i.e. extraneous solutions. 7, keep only the solutions that work in the original equation. Always go back to the very original equation, back to your sacred timeline. So those are your steps. I don't have a zoom on this camera. Get all the terms on one side so that it equals 0. It might look like a terrible mess, but it will get better. Cross multiply to get a common denominator. That's not going to make it look better. That's probably going to make it look worse. combine the rational terms into one fraction that equals 0. Multiply both sides by the denominator. And that can introduce these extraneous solutions. Now it's just a polynomial. So I kind of forgot right here, simplify and solve, right? It might be a polynomial that looks bad, but once you simplify, it's going to be a quadratic equation, almost certainly, that you can solve either by factoring or by the quadratic formula. You're going to generate one or more solutions, so check your solutions for low covariance, and then keep only the solutions that work in the original equation. That might be one solution, that might be both solutions, or that might be no solutions. Any of the three are possible. All right, end of recording.